Hi students, we're going to talk about lesson 10.4 today, where it's called inscribed angles is the idea of it. So I'm actually going to start off with the warm-ups on this one because these are really good ones to look at. So if you think about angle measures that you see in this picture, and we don't necessarily have to go through all of these, but think about all of these angle measures that are in here. What you're going to see is you're going to see a central angle. So that would be AOB that's right here. That's our central angle, and looking at that in comparison with some others. So as we move out, ACB, ADB, AEB, what I want you to notice is that AOB is bigger than each one of those, and progressively they get smaller and smaller. Mainly what we're going to be talking about today is this one out here, and the fact that AOB is bigger than that angle that is out there. Okay, we're going to get into that here. So an inscribed angle has its vertex on a circle. So the vertex right here is on the circle, and so therefore angle QRS is an inscribed angle. It also says, and sides that contain chords of the circle. So the sides of the angle are going to become chords of the circle is the idea. In circle C, we have an inscribed angle here, an intercepted arc. So we have the inscribed angle, and then we have the intercepted arc. And really what I think about it as is look at it as Pac-Man. So if this is our Pac-Man that's here, he's got his little eyeball right there. And he's looking, that inscribed angle is going to intercept this arc that's right here. It's going to eat it alive and kind of go from there. So that's the idea of that inscribed angle. The intercepted arc, the part of the circle that lies between the two lines intersecting it. In circle C, the minor arc QS is intercepted by angle QRS. So understanding those parts there. There's three ways that an angle can be inscribed in a circle. So just the three different ideas, and you don't have to really know these separately, but you could have a diameter and a chord. You could have the chords going around the center, or you have the chords where they're on one side of the center. And all that this does is this just talks about the different sizes of these arcs that are going to be here and things that happen. There's really no reason to know the different cases. Every one of these is an inscribed angle here, and that's what's going to come into play there. So with an inscribed angle, if an angle is inscribed in a circle, so angle 1 is inscribed in a circle, then the measure of the angle equals 1/2 the measure of its intercepted arc. So here's the idea behind this. If we have a circle, and I'm going to put my A and my B down here, and we have our center, and I do a central angle. If I know that this arc measure down here is, let's say, 150 degrees, then I know that this angle is 150 degrees. That's the central angle. So what is true about the inscribed angle that is off of it? Remember, that is always smaller than this. And we actually know here that it's 75 degrees. It's half the measure of this arc. So whatever this arc is, you divide by 2 and you get that angle, or this angle times 2 is going to give us that arc. Okay. If two inscribed angles of a circle intercept the same arc or congruent arcs, then the angles are congruent. So think about this here. If I put some numbers to it, if AD, let's say, is 60 degrees, then the inscribed angle C off of this is going to be 30 degrees because it's half of that. But I also have an inscribed angle of angle B off of that, which would also be half of it, which would be 30, which makes those two congruent to each other. So not always knowing the measures, you still know that these two angles that are both inscribed of the same arc are congruent to each other. Okay, so let's go through some of the checks in here. So we are looking at, I'm trying to find it on mine, page 594 in the middle there. Okay, so if we look at this question, find measure of angle T. So here I've got some different things. What I'm going to notice is that this angle is inscribed and this angle is inscribed. So when I see inscribed angles, I know that they're half the measure of the arc. So if I follow that out, this angle out, I get to S, I get to V, which means the arc is SV. Now, I don't know the measure of the arc, which makes it kind of tricky to solve. But what this one is doing is that I have a second inscribed angle that is off of the same arc. So if we use the same arc, even if I don't know this measure, those are both inscribed angles off of it. Those two angles are equal to each other. So we set these two angles equal to each other, and we solve. Subtract 2x, you get x. Add 5, you get 20. So x is equal to 20. We solve for measure of angle T. So I'm going to put my 20 in here. That's going to be 60 minus 5, which is going to give me 55. So letter D is my correct answer there. Okay, inscribed polygons. So in an inscribed polygon, all of the vertices of the polygon lie on a circle. Inscribed triangles and quadrilaterals have special properties. So an inscribed angle of a triangle intercepts a diameter of or semicircle if and only if the angle is a right angle. So what you're going to have here is if you have a circle and you know that one diameter is drawn in, okay? No matter how I draw point G, so if this is point F and this is point H, no matter where I draw point G around here, I can draw it anywhere I want. I can put it right here. If I connect to F and connect to H, that's going to be a right angle, because the other side of FH, this arc measure is 180, and that's the inscribed angle, which is going to be half of that 180. Okay, so it's going to be 90 degrees in that case. So that's what this is saying here, is really just looking at that idea and saying, okay, if we have a diameter, then 180 degrees is what we have. No matter where I put point G, that's going to be a 90-degree angle off of FH, as long as I keep that as my intercepted arc. Okay. While many different types of triangles, including right triangles, can be described in a circle, only certain quadrilaterals can be inscribed in a circle. Okay, so we're going to inscribe certain quadrilaterals in a circle. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So what this is saying here is that angle K and angle M add together equal to 180. Here's the reason behind it. If you look at angle K opens up to arc LMN. Okay, and angle M opens up, the intercepted arc is arc LN. Well, let's look at it this way, is if I call this X and I'm going to call this Y, okay, we know that X plus Y, trying to color code this, is equal to 360 degrees. Okay, so if X plus Y is equal to 360 degrees, and we don't know the inscribed angles, but we do know that the angle that is off of Y is going to be half the measure of Y, and we know that the angle that's off of X is going to be half the measure of X, then what we should know is that if that's what's given here, is that half of X and half of Y is what K and M are, then if I look at the idea that M, the measure of angle M, plus the measure of angle K, and it's going to be equal to half the measure of this, which is going to be 180. So what do we know about two angles that add up to 180? They're considered supplementary angles, and we can go through that and get that idea. Okay, so if we keep going with these examples here, our examples at the bottom of page 595 here, what I'm going to look at is I have inscribed angles. So immediately I'm going to see I have a diameter and I have an inscribed angle here. When I see the diameter, I know that this arc out here is 180 degrees, and I think that's going to play into it. I don't know what either of those other two arcs are, but what I do know is that the angle that's made off of it from T to V, and if I can connect to one point, which I do to U, that is an inscribed angle that intercepts this 180 degrees, which means angle U is a 90-degree angle. Well, now that I've filled that in, I have three angles of a triangle, and those three angles, the 90 plus the 2x minus 4 plus the 7x minus 5, are angles of a triangle is equal to 180. So I can combine all of my numbers here. So 2x plus 7x is 9x. I'm actually going to subtract the 90 over right away, just to make this slightly easier. -4 and -5 is -9 equal to 90. Add 9, I'm going to get 9x equal to 99. Divide by 9, I'm going to get my x value to come out to be 11. I want to solve for angle V, so I'm going to put my 11 in for my x that's up here. 2 times 11 is 22. Minus 4 is going to give me 18 in this one. And so that's what we're going to get there. Okay, if we look at the jewelry example, so this has a quadrilateral, so it's the bottom of page 596. This has a quadrilateral inscribed in a circle. So we have that circle that's there, and we have that quadrilateral that's inscribed. Remember, what we know in that case is that the opposite angles are going to be supplementary. And what you should notice here is we have different variables. So yes, I could set up and say all of the angles added up equal 360, but then I have two variables and I have only one equation, so we can't solve that. So what I do know here is that these opposite angles are supplementary to each other. So I know that 12y plus 6 plus 11y plus 13 is equal to 180. And I also know that 5x plus 2 plus 8x minus 17 is equal to 180. So with that information, we can start to solve. So I can get 13x minus 15 equal to 180. Add 15 to the other side, you get 13x equal to 195. And when you divide by 13, your x in this case is going to come out to, sorry, I didn't have this one ready. 195 divided by 13 is going to come out to 15. And then once you have x, you can solve for j or L. That's going to be the j that's here. So once we have x, we can solve for j. So we're going to do 5 times 15 plus 2, and we're going to get 77 for an answer. So our C is going to be our answer there. Then we go solve this other one. So add my y's together. I get 23y plus 19 equal to 180. Subtract that 19. So 180 minus 19 gives me 161. So we have 23y equal to 161. Divide by 23, and that's going to give me a y equal to 7. I need to find angle K, so I'm going to come over and find angle K here. So I'm going to do 11 times my y of 7 plus 13. So I'm going to do 77 plus 13, and I'm going to get 90. So this comes out to a 90-degree angle there. Okay, so solving those, again, with those opposite angles supplementary. Okay, so that's what you have for now, and you can do your homework.